Excellent. So I am in the third video for Smart Lab number 2. And we're going to hit objective 1 in this video. We're going to measure and analyze some filters. So in Pro Tools, I think the first thing to do is put a filter plugin on our measurement track. Okay, we're going to leave the reference alone and we're not listening to the sign at all. So let's use the big boy free one from Pro Tools. Going to plugin, EQ, and the EQ 3.7 band. And y'all should be pretty familiar with this one. And I highly recommend, if you can, it'd be nice to hear what you're doing. I'm going to have it muted so you can hear me better, but I can actually bring it up here, and if I do a little change here, I can hear that. So, if you've got a way, now you may not actually have a way to do that. If you have a headphone jack on your audio interface, that I would use that so you can kind of hear what you're doing. But it's a bit complicated because obviously Pro Tools is going out of the headphone jack and going into the audio interface, so it's a little complicated. So if you can, take a listen to anything you do. It kind of reinforces your eyes to have your ears working. But anyway, we're getting started here. I've got this EQ going. I've got a transfer curve still operating, and it's flat right in the middle. And I want you to do some experiments, and hopefully with your ears as well, kind of see what happens with phase. If you boost up, big treble boost there, like you can see the treble boost, and you can see this odd little phase response. So, what's going on there? You may even want to, if you can, and I'm using a control right now to zoom in on the Live IR control drag. That's on a Mac. You can even see what's going on with the Live IR trace too, because changes on here. It's interesting. You can really see that the effect of the group delay is elongating the impulse, making it longer in time. You'd also find some interesting things out that low frequency changes, which of course are going to create low frequency phase shift. And please experiment with this, like see what boosts do and what cuts do. You'll see that the phase shift change is always inverse of what the amplitude changes. But you'll notice that down in the low frequencies, movements don't actually affect the Live IR very much, where high frequency changes really do. And that's because the Live IR is linear in its frequency measurement. It doesn't have very good resolution down in the low frequencies. There's not as many frequencies down there being analyzed. So that's an important thing to kind of reinforce in your mind. But play with this. Spend some time and take. It's kind of nerdy. Just really kind of see what this phase shift is like. That's always a strange one. Really sharp filters like that. And along the way, if you're getting impatient, hit V and it will just redraw the screen right away. It kind of resets the averager, so that's a really important feature to understand in Pro Tools is about the in Smaart, it's the V key. So when you're done with your experimentation, just bypass the plugin. Cool. Again, I could speed that process up with the V key. And now we're going to get into the meat of this and your actual objective. You're going to do some measurements of filters and their associated phase shift. So what you're going to want to do is we're going to turn on our high pass filter here, and we're going to set it. Let's see, we'll make what the assignment says 200 hertz. So I'm going to type 200 in there. We should probably be. Oh, I'm in bypass. That's the problem. Oh, I need to actually not bypass, but factory default this whole thing. Let's type this in again. 200 hertz. And again, it's a high pass filter, and I'm turning it on. It's a 6 dB per octave filter, and I'm going out of bypass now. 6 dB per octave high pass filter. So there's a term called order. For every 6 dB of cut per octave is another order. So this is a first order filter because it is a 6 dB per octave filter, and you can see the associated phase shift. So this is basic response. Let's take and capture the screen of this, and you need to do this for your assignment. So you're going to use your first name. So I'm Eric, and I'm going to call it first order HPF. And I don't know if I can do this in Smaart, but I'm going to copy that. Copy, so I don't have to type that in multiple times. And cool, and that shows up over there. And let's go ahead and increase the order. So back to Slow Tools here. And I'm going to just slide this off the screen while I'm watching. And I'm going to go, let's go second order, or what's also known as 12 dB per octave. So slide this knob up one notch, 12 dB per octave. If you wanted this to be speedier, hit the V key. And hit the space bar or hit the capture button down here if you want. And let's try Eric dot, and I'm going to do that paste. Oh, sweet. I don't have to do that 20 times. And really, oh, it's second order, right? Second order HPF, because we've made a second order. And we're going to continue on. We're going to do this through the fourth order. So let's slide this up to 18 dB per octave, which is our third order. And I'm going to reset the Avoger with the V key. And I'm going to spacebar it, and I'm going to say it's Eric dot third order. So I got to, really what I should do is just copy from that point on. Just in time to do the last one. Let's go over here. Let's drag this all the way up to fourth order. Reset it pretty quickly with the V key, and don't worry about this gibberish. That's just, it can't catch it, can't pick it up, because it's not there. And hit the enter key, the space bar, and Eric dot fourth order, right? Oops, should have typed fourth there. Fourth order. So there you go. You can kind of see the relationship between amplitude and phase, and you can really see that the mellower the slope of amplitude change, the mellower the phase response. I mean, that's pretty obvious. And what's actually going on here is every time we go up by an order at the turnover frequency, at the cutoff frequency there, you will see exactly 45 degrees more phase shift, and that's the rule. Let's repeat this whole entire process for the low-pass filter. So I'm going to disengage this bad boy. We don't need it anymore. I'm going to turn on the low-pass filter, and the assignment request, I think it's 8,000 hertz. So let's put this, no, where's it, 5,000? Just make sure I do it correctly. 5K. So let's put 5,000 in there, and what does it do? 5K. Let's turn it on. And I've got a first order filter here, right? 6 dB per octave. And let's capture it. And so it's going to be Eric dot first order, in this case LPF for low pass filter, and I'm just going to select order. I'll just click the whole thing. We'll just, cool. And I think you know what I'm going to do here. I'm going to move this to be a second order filter, and hit the V key, make it fast, space bar it, and it's going to be Eric second order low pass filter. And let's do the third one here, and V and space bar, Eric third order. We're almost there. And my fourth order filter. So one more up, and V key to make it fast, space bar, and Eric fourth order. So now you really can see the response here of all the different filters. Now, yeah, really, you probably should hide these first guides so you can really kind of see what's going on with the phase shift. Look, you have a total wrap here, and with a fourth order filter, and that makes sense because 45s, you get 45 degrees of phase shift per order. 4 times 45 is 180, and that's 180 there, right? A reverse in polarity or an invert. It's not really, or an inverse in phase there. So that's what's going on. So you are going to, for your deliverable for this first practice assignment, just turn all these on. Take a screenshot. I'm not going to tell you what the keyboard command is because I use a different one on my computer. But take a screenshot of this whole thing. Please name it exactly as described in the instructions, which is your first name dot filters, and that's what you're going to submit to Canvas. Okay, cool. And this third video.